Hi everybody, let's look at number 3 from section 4.8. We have iodine 131 is a radioactive material that decays according to the function A of T equals A naught times e to the negative 0.087 T, where A naught is the initial amount present and A is the amount present at time T in days. Assume that the scientist initially has a sample of 200 grams of iodine 131. We want to know what is the decay rate of iodine 131, how much iodine 131 is left after 5 days, and when will 100 grams of iodine be left. So in this case we do see that we're dealing with decay, and it makes sense because the K is negative here. And the equation that we'll have is A of T equals A naught, but we're told that the initial amount is 200, so 200 times e to the negative 0.087 T. And the first question is asking, what is the decay rate of iodine 131? So the decay rate is K, and that's going to be the negative 0.087, or we can write it as negative 8.7%. The next question is, how much iodine 131 is left after 5 days? So T is representing the time in days, so we'll replace T with 5 in our function. This means we'll have A of 5 equals 200 times e to the negative 0.087 times 5. Punching this in our calculator, we'll find that this is approximately 129.45 grams. And the last question is, when will 100 grams of iodine be left? Notice at the get-go, we're essentially asking what's the half-life? How many years will it take for half of the radioactive material to decay? And so half of 200 is 100, so that's our A of T. And we're solving for T, so we're going to want to divide both sides by 200. This will mean we'll end up with 1/2 times e to the negative 0.087 T. And the thing to notice, just to make some connections, is that I mentioned we're finding the half-life. That's why we have 1/2 here. When we were finding doubling times, this was 2. If we needed to find like triple something, this would be 3. Okay, so that's just a nice little connection. To solve for T, we'll need to natural log both sides. And when we natural log both sides, the negative 0.087 T will come down as a factor, and natural log of E is 1. So to solve for T, we can divide both sides by negative 0.087. So T will equal natural log 1/2 divided by negative 0.087. This is approximately 7.967 days. And so what we can conclude is in about 8 days, half of the radioactive material will remain. Alright, I'll see you in the next video.